Alright, my people, we are so back. It is January 14th. It is now 5:20 p.m. I woke up way too late to be doing it in the morning. I had work, so I decided, you know what, I'll do it in the evening. Yesterday, I had an OA. There were 3 parts to it. I did amazing on the first and second part. The third part, incredibly hard. Maybe the hardest question I've done in my life. Suffice it to say, it did not go well. But that is okay. That is why we're doing this. One day, there will come an OA question just like that or harder, and I will get it. So, let's go. What a sell. I could have clutched it. But it is okay. It's fine, guys. Let's do flood fill. Hello, hello. Okay. Just making sure. Flood fill. Alright. Okay. Ooh. You are given an image. Oh my god. M by X grid of integers image, where image ij represents the pixel value of the image. You're also given 3 integers, SR, SC, and color. Your task is to perform a flood fill on the image starting from SR, SC. Row and column, I'm getting starting row, starting column. To perform a flood fill, begin with the starting pixel and change its color. Perform the same process for each pixel that is directly adjacent, so like this way and this way. What about the diagonal? But it says pixels that share horizontally. Okay. Keep repeating the process by checking the neighboring pixels of the updated, modifying their color to match the original color of the starting pixel. The process stops when there are no more adjacent pixels of the original color to update. I don't completely understand. And there are no more adjacent pixels of the original color to update. Oh. How do I do this? So the way I think about it, like the way I'm thinking about it is like, wow, this is like, wow, okay. Technically it's day, does it count as day 14? I did an OA yesterday, but I didn't do a leak code. Yeah, we'll just call it day 13, whatever. Day 13/14, whatever. Maybe we'll do 2 questions today. Who knows? Okay. Do I just, if this is my grid, I start here. I need to make this a 2. So I go 2, and then I could do it like this. That's what I'm thinking. So I go here, go 2, 2, then I move to the next one, go 2, 2, and then here, and then I go 2. But what if, see, this works in this case, but what if it was like, it was like 1, 1, 1, 1, 1, 1, 1. Because then I would go 2, 2, 2, 2, 2. No, that's not the one I want to think about. So I'm just going down and filling all of them. Why would I not fill this? So if it's 0, for this one, I'll check haze, the one before it. Oh, but it can start anywhere. What if it starts here? Like my way will only go like to the right and down. What if like the starting pixel is in the middle? What if their like starting row is... Oh, because this is the starting row. Wow. Bro, how would I do that? Depth first search. Isn't that what I did? Depth first search. Depth first search. Let me try something. I'm gonna try and just watch a video on it, because I'm not really sure. I don't even know what to pick from. Let's just pick this guy, right?
Hey, what's up guys? ThinkWhite here. I do tech and coding stuff on Twitch and YouTube. Check the description for all my information. I do the premium late code problems on my Patreon. Join the Discord, message me. I try and get back to everyone. This is an easy problem called flood fill. Pretty cool. 733, a lot of likes. An image is represented by a 2D array of integers, each integer representing the pixel of an image from 0 to 65,535. So we got a 2D array of a bunch of pixels, and it represents an image. Given a coordinates, SRSC representing the starting pixel, row and column, so row and column of the starting pixel of the flood fill, and a pixel value new color, flood fill the image. So we want to flood fill an image from a starting pixel. To perform a flood fill, consider the starting pixel plus any pixels connected forward directionally to the starting pixel of the same color as the starting pixel. Okay, so that's important. Same color as the starting pixel. Plus any pixels connected forward directionally to those pixels also with the same color as the starting pixel, and so on. Replace the color of all aforementioned pixels with the new color. At the end, return the modified image. Okay, great. Instantly, this reminds me of Number of Islands. If you guys saw that, if you didn't, maybe check that out. But it's an easier version of it actually, so maybe watch this one first. But let's just go through an example. So this is all our inputs. This is a lot. We got a lot of inputs here, right? We're given an image as a 2D array. And I like to look at 2D arrays like this. I think it just looks a lot cleaner. When you look at it like kind of like a square, you know, you could visualize a little bit better. Maybe use that as a strategy. And our output looks like this. So let's also get that, right? So how do we get from...
This is cool. Maybe I should think about it like this too. I'm gonna try and... I'm also gonna do the same thing. I guess it does help. But I mean, it's good that here they already have this. I want to see what he's doing like this. And then he says output. Output is like
from here to here, right? We have a starting pixel, which is 1, 1, position 1, 1. So 0th row, 1 row, and then first column, 0 column, 1 column. So this is where we're starting at 1, and we're wanting to make the integers represent colors in this. So we want to make the color turn from, the color right now is 1. We want to turn the color to a 2. So we would, what we do is we start at the starting pixel and we change it to a 2. And then we change all of the colors that are equal. Remember, same color as the starting pixel, 4 directionally to 2s. So we started here. This is our input. We see the starting row, starting column is 1, 1. So if you know indices of 2D arrays, 0 row, 1 row, 0 column, 1 column. Turn that to a 2. Now 4 directionally, anything that was a 1, because 1 is the starting color, you can change to a 2. So you could change its up, left, right, and down. These are zeros. These are not the same as the 1 that was there. So you cannot change these to 2s. So this is a 2, but we can change these 1s to 2s because they are the same as the starting pixel color. Boom. Okay, we're good to go there. 2, 2, 2. Now from these, you have to change. You also change all the ones that are anything you change, you keep going 4 directionally from there. So we see more ones to the bottom, top, and then this one to the right. Boom, all of them, because it's 4 directionally from these. So you got the top down, and then left, right, which is already done, and then this one. You cannot reach this one because there's no way to get there going down and to the right. This is diagonal, so there's no diagonal connection. So that's how it ends up like this, just in case you guys were curious about that. So what you'll notice is we do need to keep track of what the color was at the beginning so that we only change things that are the same color as what we had at the beginning. For a strategy to do this, we're going to be using depth first search, where we do recursive calls. Let's just get into the coding right now. But we're going to modularize.
So, just want to, somewhere along the way we'll be going. Okay, let me just follow him.
Doesn't make a separate little method here called fill. So, or you could call, let's just call it fill. That's pretty good. So it's a void method. It does nothing. Fill, and this will fill a current pixel, just 1 pixel. So this will take in the pretty much the same as this, like the same parameters, except it will also take in the previous color. So we can it'll take in the starting color, so we can make sure that we're doing this correctly and we're only changing the starting colors to the new colors. So what this will do is it'll say, okay, at the current row and column, we're just going to make that equal to new color because it's going to
That makes sense. It's just like
be equal to the old color. And we do want to assume that we also will. We'll check. We'll be like, okay, if image SR of SC is not equal to color, that's bad. Or the row is less than 0, so it's index out of bounds, or the
image SRSC is not equal to color. Maybe that's better. Starting row.
column is less than 0, so column index out of bounds. Or, the index is greater than or equal to image.length, so that's bad too because that's out of bounds because the only index it can go up to is image.length minus 1. Column is greater than or equal to image of 0.length, so the column index is out.
Bro, what? Starting row is if the row is greater than the image length. Yeah. Oh, I was just checking to see if it's greater than the... I didn't even do that, bro. Image is greater than...
Out of bounds. So you check all those. And what we'll do is if any of these conditions ring true, we'll just return. We won't do anything. So this method will do nothing if any of these, errors occur. Like we're not finding, this is the, if it's not equal to the starting color, why would we change it to the new color? Like we're not doing that. Because the starting color is 1 in this. If we found a 0, we don't want to change it. We just want to return. But if the index is in bounds and the color is equal to the starting color, we want to change that thing. And so yeah, and what we want to do is we want to call this method over and over again, and we want to call it on, passing the parameters in image the row plus 1. We'll do the row before, so to the left. Actually that's to the top. Row before is to the top. SC, the same column.
SR minus 1. What does that mean?
Column, color, and new color, and then we'll repeat this 4 times because you're going 4 directions. So what you're doing is the row before, so the top, row after to the bottom, same row, but now to the left and to the right with the columns. So that's it. The row before, row after, column after, and then this recursively just calls doing a depth first search. If you guys don't know what depth first search is, it's gonna keep recursively calling until it hits this return, and then the next line, and then the next line. It's look up depth first search. This isn't a depth first search course, but it is a great searching algorithm for problems like this. This is a very common algorithm problem style with 2D arrays. There's a lot of questions that involve like depth first search like this. So now we just want to call fill. So all we want to do here is, well, first of all, if the image of SR if the starting pixel is equal to new color, we'll just return the image because it's already done from what we understand. Why would you? They should give us a starting pixel with an original color, right? Then we just have to call the fill method with the.
Is that what they said? I guess so. That makes sense. I guess why would you? I'm just thinking about like MS Paint. If you put the same color on top, it's not gonna like go over and check everything, you know, so it makes sense.
Exact information. The starting image array, the 2D array, the starting column, the starting row, and then the color is just going to be whatever the current color is. You know, the index they gave us. It should not be new color. So this is the original color. So, you know, you look up that, like in this case, you know, we saw that one. We passed that one in. We're like, okay, this is the color, and then we have the new color, actual parameter. And then after that, after this gets called, it'll do all of this stuff, recursively calling, do all of those, you know, left, right, top, bottoms over and over again. And then we get our image back. We can return it, smooth sailing from there. Till you get an index out of bounds, guys. Then you're screwed. So, you know, never mind about that. Where is this? What are we doing wrong, guys?
So it's gonna call it one time. Okay, so this is just checking. Why can't I access it? this is inside. this works. Should I just do it like remove the equal sign? Oh. Okay. So I need to double check. I mean, make sure like the front part is true before the end part. I did not know that. There's an algorithm that starts with spread out to adjacent square, replacing a color with a new color. Different color reaches the boundaries of the grid. The current pixel is outside the bounds of the grid. Stop. It is not the same color as the starting color. Stop. If the current pixel has already been filled with a new color. Stop. The current pixel has already been filled with a option to fill in. JSON. Its color doesn't match the starting pixel. Nice. I feel like this time I actually just would say it's O of n because I would say it's O of n because you need to check every single one. You need to check every single, almost every single, but basically every single node at worst. Yes. Yeah. And it's O of 1 because we're not making anything new. We're just taking the same one. But I guess maybe we're making a different function. But it still should be O of 1. Because we're not, like, the amount of space we're taking in memory is the same, no? Yeah, we're not, like, making another list. I guess I should say O of n times m. Because that's how many... I mean like O of n as in the size of the array, but I guess I should say O of n times n. That's the more correct way of saying it. I need to remember that in these type of questions. Oh, really? Oh, because this is kind of storing. Oh, because you have to like hold on to it. Oh, okay. Cool. There we go. A little tired today, I'm not gonna lie, but we got it done. Sounds good. I guess today's day 13. We're officially 1 day behind. So maybe on the weekend or something, I'm just gonna do like 2 videos. So I'm like, kind of doing 2 questions, kind of try to catch up. Or maybe we'll just keep going, whatever. It's fine. I mean, I did do something yesterday, but it wasn't like, the official. Okay, whatever. See you tomorrow.